Monthly Space News highlights what we're going to cover. Blue Origin has been chosen by NASA for the second moon lander. Virgin 1 orbit, they're gone forever. They've sold off the assets. They won't be coming back. And also we'll talk about recent launches to space. So, Blue Origin, second Artemis lunar lander. Fundamentally, NASA and others have wanted to have competition for SpaceX because SpaceX has the first human landing system. That's another name for the lunar lander for the Artemis program. You know, SpaceX had been chosen for Starship to be the first one, and they wanted a second one. There were two teams competing, and they picked Blue Origin. And mainly just to have competition is what it comes down to. Blue Origin 1, they are teamed. They're not really by themselves. They actually teamed with a whole long list of people. Lockheed Martin, Draper, which was part of MIT a long time ago, Draper Labs. Honeybee, we talked about them one time, maybe 6 months ago. Astrobotic and Boeing. And they did this for a fixed price, a lot lower than their bid the last time around, $3.4 billion and fixed price. So that's quite a change. NASA really is trying to move more to fixed price contracts. You know, they had this long history of just doing everything cost plus, where everything cost a whole lot more when all was said and done. And they really are switching on this. The other thing is that Blue Origin will be essentially matching this. They're going to invest about half of the total cost of their own fund. That's part of the advantage for NASA to tie in with all these other companies, is to share the development cost and the risk. Okay, Virgin Orbit. Now, they're the ones that were doing launch to orbit of small satellites. This is different than Virgin Galactic. Both are Richard Branson originally. Virgin Galactic was the first company they spun off as Virgin Orbit. So they have a plane like that 747 you see up there. They would drop the rocket from that, and then the rocket would take a small payload up to orbit. And they have succeeded a couple of times. They've also failed a few times. And, you know, so they've done both of those things. But as a result of not really moving very fast and not being all that successful, they're going bankrupt. They had an auction. The assets were all auctioned off, including an airplane. And that was a total of $36 million. Now, you think about that, that's pretty much what they're saying the company was worth. It was originally valued at $3 billion in their IPO when they first went public. And in fact, for a little while, the price even went up from there. They did Chapter 11, bankruptcy. Normally, you figure everybody will take a haircut, they'll lose some money, they'll reorganize the company, and they'll go back in business. Nobody wanted to buy into it, so they just pretty much gave it up and sold it off, and that's it. Okay, so who bought this stuff? Well, Stratolaunch, they bought the 747. This is a company that actually is selling mainly to the Defense Department. When people want to experiment with hypersonic missiles, they want to have something up in the air they can drop it, and then they can go retrieve things, they can reuse the plane. So Stratolaunch saw a good use for that 747 and dropping.
The big double body.
They have another plane which they were also doing. So this is really their second one. Rocket Lab, which also makes small rockets, they weren't interested in the rockets themselves. What they wanted was the headquarters building because it's just down the street from them. 3D printers, a specialized tank welding machine, and so on. And then VAST. Now, this is the company that's going to be building space stations, but with artificial gravity, unlike all the others like Axiom. They're actually going to have artificial gravity. They bought the facility in Mojave, California, and some machinery to go with it. So that's what happens to this stuff. What's interesting is that where was all the rest of the value? You'd think it might have been in intellectual property. You think, well, they must have developed a lot of good stuff, a lot of good patents. Nobody bought any of it. Nobody even thought it was worth buying. It's rather sad, actually. Nobody wanted the rockets, of course, because they're really kind of specialized, but nobody even wanted to pay for the intellectual property. Usually there's somebody buys patents. This sort of it's almost unusual that didn't happen. So why is it? They're gone forever now. Why is that? Well, first of all, some of it is company specific. They didn't really develop things all that fast, and there were some failures, kind of high profile, and it got noticed. One of the bigger problems, though, is simply the competition. Others have lower cost and higher reliability and are proven at that. Now, SpaceX has a much bigger rocket, but what they do is they bundle up in one launch. They'll bundle up 100 satellites, and they'll launch them all at once into the orbit they pick. And then now there's all these people that make space tugs that can move you around to the orbit you actually want. And that whole process is so much cheaper than the individual launches. So that kind of kills them right there. Rocket Lab is one of the few remaining small launchers. They're building a lot of other business on parts to sell for satellites and that sort of thing. They're still hanging in there, but they are the next biggest competitor, and they're still hanging in there, and they were still cheaper. Their cost to launch was still cheaper than the airplane. And finally, it's really just kind of a small market. When you get down to it, It's a small payload, 500 kilograms, so maybe, what, 1,100 pounds to low Earth orbit. There is a market for that, but it's being mostly absorbed by SpaceX and Rocket Lab these days. They do have one special advantage, though, and that's that you can take off from any airfield. And that was really their main selling point. The problem is, it's mainly the military that really cares about that, and there just wasn't that much of a market yet for it. So the rapid response is of appeal to the military, but other companies like Rocket Lab are picking up that business, so it's not going away. And there's actually one final thing that we tend to forget, and that's that when we first heard about this whole idea of using an airplane to get up there, essentially using the airplane as the booster, you think, well, that's really cool. It's just a jet. It's easy. It's cheap. You get it up really high and it goes really fast. Not so much. You look at it from an energy standpoint. Kinetic energy, if you're going to orbit, you're talking 17,500 miles per hour, something in that range. At an airplane like this, maybe you get to 500. I don't even know what their exact number was, but say you got to 500 miles an hour. You compare that to 17,500, and you realize that the energy involved is a square of that ratio. It says that you get 0.08% of the energy. That's the benefit you get from that booster. That's just not enough to be competitive with other boosters. And even the potential energy standpoint, you're going up high, it's just proportional to the height, the altitude above the sky. Maybe you get up, say 8 miles if you go up in a jet, maybe that's 45,000 feet. Maybe you get a little higher than that, but you have to get up at least a couple hundred miles to get the low Earth orbit. The lowest orbit is maybe 120 miles, but very few people want one that low because you end up decaying pretty quickly. So the percentages just aren't there. It's just basically the benefits weren't really there, and I think that ultimately killed them. Okay.
Great.
Yeah.
Want to go halvesies on a rocket? I know where you can get
I know where you can get 6 of them
for 2 weeks, and then I get to keep it 2 weeks.
Well, actually, there's a catch. Most of those rockets weren't actually finished yet. They were actually in various stages of assembly. So you have some work to do. I'll take the finished one.
I got it the first week, I guess.
Okay, moving on. Launches. We like to have people guess how many launches have we had since the last meeting, which was May 13th. Okay, that's 38 is one guess.
20?
Well, you're a clock closer than the 38. Okay, well, I'll start giving you a couple clues. Okay, did you account for this one? This was the Chinese launch to their space station back on May 30th, bringing up a crew of 3. And by the way, kind of a side comment here, because those 3 went up while the original crew of 3 is still there, that meant they have 6 people on their space station. It's normally staffed by 3, but short term they can have 6 there. And you had kind of the same thing going on at the International Space Station. They had an extra 4 people there because of the Axiom private mission. They had an extra 4 people there that weren't there normally. So you add the 2 up, there were 6 people in the Chinese station and 11 on the International Space Station. That's 17 people who were in space at the same time. That is actually a record. And that particular rocket there was part of it. So that was one of the launches.
There were a couple more. Count for those 4 hours.
Yeah. Okay. I guess. Yeah, I wasn't actually counting the suborbital kind of things like that. To me, those don't really count. That's just sort of noise. It's sort of, it doesn't result in anything significant. So yeah, but 17 people were there actually orbiting. For more than 10 minutes. I mean, we're talking a significant period of time. Having a tourist visit for 10 minutes doesn't really count for much. Okay, next one. Who launched this rocket? Can anybody take a guess what that is? This is North Korea.
Oh.
Yeah. And who knew that they had such a picturesque site? Huh? I mean, I didn't know that. So yeah, this is their launch site. They launched this thing called the Kolyma 1 on the 30th, and they actually had pictures. So this is kind of unusual for them. They're usually much more secretive. They're trying to broadcast to the world that they have this capability. So now they're kind of going the other way and actually publicizing things. So that's a picture of their rocket. I mean, we know that did happen. Now it failed, this particular one, but it still counts on our count of missions because they were attempting to get to orbit. They were trying to put spy satellites up, and they got off the launch pad. And so they attempted it, they got off the launch pad, it was a second stage that failed. So they count. Okay, another one. What is this? Besides, okay, it's a satellite. I'll give you that. But anybody know whose satellite that is? Okay, it's a Chinese satellite. This is their first test to test their equivalent of the Starlink satellites. They set them up so they're easy to stack up as flat, as flat as possible, so that you can kind of spew them out like they're doing with Starlink communication satellites. The reason I ask that is if that's the final thing that's coming, what it was going to look like, there's another 13,000 of those coming. So they are definitely going to be competing with Starlink, and this is their first attempt. They launched it on one particular rocket, which was a solid fuel rocket, strangely enough. But I'm sure they have lots of possibilities for launch. But the main thing is they got one up now there for testing purposes, and this may be getting close. It's kind of a copy of Starlink, and the original Starlink satellites were kind of flat, and they had the solar panels just sticking out on one side. The new Starlink satellites actually have solar panels on both sides, so they're a little different than that. Okay, so here's the launches that we've had. There were 19 satellites, 19 launches altogether. And I've already touched on a lot of them. The Axiom mission to the space station, the Chinese and North Koreans and so on. Just a lot of the typical kind of stuff. A lot of Starlink launches. The unusual ones here were North Korea. I had to go dig up the flag for North Korea. That wasn't really an issue before.
I'll make one other observation, and that is all of those American launches are Falcon submarines.
Yeah, Falcon. Yeah, basically SpaceX. Yeah, SpaceX dominant. And if you look at it in terms of how much mass has been lifted, I mean, it's even more significantly almost all SpaceX basically, because the Rocket Lab launches are very small, small satellites. So when you get down to it, really pretty much Japan, the European Space Agency, and Russia have pretty much given up against competing against SpaceX for launch. Now, they're still going to be in the game with their own rockets, for military purposes, or for keeping a capability there so they can build stuff militarily when they need to. But from a commercial market standpoint, they're out of the picture. They're all gone. The Chinese are really the only ones that are likely to be in there, and they're starting work on their reusable stuff. It'll be a while before they're all in place, but they're taking it seriously. Unlike the Europeans, who their new rocket isn't even going to compete against the Falcon 9, and it's not even working yet. The Falcon 9's been around for 10 years, so yeah, it's all pretty much SpaceX. That'll change when Project Kuiper comes along. This is the Amazon satellite-based internet. They're basically keeping the rest of the industry alive because they refuse to contract to SpaceX. So when they're putting up their thousands and thousands of satellites, they're using everybody else's rockets. They've essentially provided a lifeline to everybody else. So they're all staying in there. But they'll be more expensive. They'll be a lot more expensive until they get their own Blue Origin rockets going. Okay, that's it. Other space-related videos or slide presentations by me are available at the link shown here. That includes a web page and also a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.